We all have this picture in our heads of how our solar system got started. But what if that picture is, well, wrong? What if the very beginning of the story, the part we thought we had figured out, needs a complete rewrite? That's what we're digging into today, a fascinating new theory that might just change everything we know about our cosmic origins. And look, this isn't just some random what if. For decades, the story of our sun's birth pointed to one prime suspect. But now we've got new forensic evidence, literally hidden inside ancient meteorites, that says the official story, it just doesn't add up. So the clues are these amazing chemical fingerprints left behind in the oldest stuff we've ever been able to get our hands on. And what they show is this. We find a ton of radioactive aluminum-26, but almost no radioactive iron-60. And right there, that's a huge problem. It's a cosmic contradiction, because our go-to theory has always said that those two elements, they should have shown up together. And this isn't just me saying it. The scientists who found this actually wrote that this discrepancy, quote, challenges the assumption that a nearby supernova was responsible. In other words, the evidence left at the crime scene just doesn't match the suspect's MO. The whole case is being called into question. So what we've got on our hands is a genuine cosmic cold case. The clues that were left behind in all this primordial stardust, they're pointing in a completely new direction. It's forcing us to reopen the books on our own origin story. You see, the old theory was just so neat. A massive star goes boom nearby. The shockwave from that explosion does two things. It kickstarts the collapse of a gas cloud to form our sun, and it sprinkles that cloud with all these heavy radioactive elements. It was the perfect suspect. Almost. Okay, so here's the smoking gun. This is where the case against the supernova just falls apart. A supernova should deliver a boatload of both of these isotopes. And sure enough, we got the aluminum-26, check. But the iron-60, the delivery truck never showed up. It's way, way lower than it should be. The fingerprints, they just don't match. Case closed on that theory. So, if the supernova didn't do it, who did? Well, it's time to meet a new character in our story. A much more interesting culprit, if you ask me. A giant, volatile, bubble-blowing star called a Wolf-Rayet star. So what is a Wolf-Rayet star? Oh man, it's an absolute beast. Think of a star more than 25 times the mass of our sun, right at the end of its life. It's burning unbelievably hot, and it's not waiting to explode. It's actively throwing off huge chunks of itself through these incredibly powerful stellar winds, long before it ever goes supernova. And those stellar winds, they act like a cosmic snowplow. They push and push, carving out this gigantic bubble in space. What you get is a really hot, basically empty cavity in the middle, and it's surrounded by a super dense, cold shell of gas and dust. And it's inside that shell, that's where our story really gets going. So the new theory ditches the idea of a violent, messy explosion. Instead, it proposes something way more elegant, a kind of cosmic delivery service, using stardust itself as the truck to get the goods where they need to go. So how does this work? It's a brilliant four-step process. First, the Wolf-Rayet star forges aluminum-26 deep inside and then blasts it out with its winds. Then, that aluminum literally sticks to tiny dust grains. These grains, think of them like tiny armored drones, get shot across that empty bubble. And finally, they slam into that dense outer shell and deliver their precious cargo. And the absolute key to this entire incredible process? It comes down to one tiny, tiny detail: the size of those dust grains. We're talking about 1 micrometer across. It sounds impossibly small, right? But as you're about to see, that specific size is the secret sauce that makes the whole thing work. Yeah, this 1 micrometer size is the perfect Goldilocks solution. See, if the grains were any smaller, they'd just get vaporized by the heat inside the bubble. Poof, gone. Any bigger, and the stellar winds wouldn't be strong enough to push them all the way across. But this size? It's just right. It gives them enough oomph to survive the trip and actually punch into that dense outer shell, delivering their aluminum right before they get destroyed. They're perfect little cosmic delivery capsules. Okay, so we've got our delivery system figured out. Now let's get to the main event. Let's see how this whole process doesn't just deliver some aluminum, but actually triggers the birth of an entire solar system, all tucked away inside this enriched cosmic cocoon. All right, let's walk through this. Imagine you see those little specks there. Those are our dust grains, loaded up with aluminum-26. They are flying away from that central star, shooting across the empty bubble and heading straight for that dense outer wall. And bam, this is the moment of impact. Those grains are moving so fast, they just pierce right into the shell. As they slam into all that cold, dense gas, they decelerate almost instantly and vaporize, releasing their entire cargo and enriching that part of the shell with all that fresh aluminum-26. And finally, with all this new material injected into it, that dense shell starts to get unstable. Pockets of it get so heavy they begin to collapse under their own gravity, breaking up into little clumps and igniting to form a whole new generation of stars. And somewhere inside that massive stellar nursery, our very own sun flickered into existence. And this solves our final mystery. What about the missing iron-60? Well, the Wolf-Rayet star does eventually go supernova, and that's when it creates tons of iron-60. But here's the twist. Turns out these explosions are often lopsided, kind of asymmetrical. So the theory is that the main blast of iron simply shot off in another direction, completely missing our little corner of the galaxy where our sign was being safely born inside that protective shell. Case closed. So if this is really our origin story, it brings up a huge question, right? Does this make us special? Does it make our solar system some kind of cosmic fluke? Or is this gentle, bubble-born method a common way for stars like our sun to form all across the galaxy? Well, it turns out this might not be rare at all. In fact, the researchers crunched the numbers and estimate that anywhere from 1% on the low end to maybe 16% of all sun-like stars could have been born in this exact same way. Our cosmic birth story might actually be pretty common. And the paper itself puts it perfectly. They say it's, quote, plausible to assume that a solar mass star is not a special case. It might even be what you'd expect to get from this process. It suggests our gentle birth, sheltered inside the shell of a cosmic bubble, could be a standard pathway for stars like ours, and for any planets that might form around them. I mean, it's just an incredible thought, isn't it? Our entire origin story, the story of you, me, and everything on this planet, was just rewritten. And it was all thanks to clues that were hidden for billions of years in tiny, tiny specks of meteorite dust. It really makes you wonder, what other incredible secrets about who we are and where we came from are just sitting out there, waiting in another speck of dust?